Hello everyone, thank you for joining for another Embedded Academy What's New. Today we have several topics. One I introduced before already, but I would like to go back into this topic because we decided to provide AutoSAR as a complete e-learning free of charge. So you can sign in, and we had the first lesson for free in the past, but now everything is for free, the whole AutoSAR course. Just a short look what this means. It means that you have an overview on AutoSAR in general, the organization, the different standards like Foundation, AutoSAR Classic, Adaptive AutoSAR, and so on. And then we go deeper into AutoSAR Classic. So all the next 4 lessons are dedicated to AutoSAR Classic, explaining the architecture and so on. One special field of the architecture is the virtual functional bus, implementing all the interfaces of a real-time environment. And there we even have 2 e-learning units, one on the introduction and one on the principles themselves. And the final part is operating system. And as you can see, in comparison to the other courses, it's really long. What does 3 hours and 50 minutes mean? Our estimate is that you need around 5 times as long as the time indicated here. So I would say at least 2 days should be invested to learn everything on AutoSAR. So this is a real treat, having this for free. And in addition, as we have it for free anyway, we are deriving videos from it. So you have a playlist on the overview, you have a playlist on AutoSAR Classic, and now this playlist on the virtual functional bus is new, and we are releasing a new video every other week right now. So if you want to learn in detail and really study AutoSAR, we recommend to take the e-learning, having a short look, looking something up. Then we can also recommend the YouTube playlists. And of course, we're happy if you sign in. Before we go into the news of the courses, I would also like to say something about the distribution network. For Asia, it's FTD Solutions, and in NAFTA, meaning it was NAFTA. So I hope that on a political basis, working together in Northern America will work also in the future. So we're talking about Canada, Mexico, and the US. And our distributor, Joral Technology, who is located in Canada, has been initiating an embedded software learning center, which is new. And there you also find our courses. They are taking our information on the learning journeys for the different job profiles and putting it on their site. So if you are someone with a business interested in educating your engineering workforce, then Joral Technologies is our contact in Northern America. So I wanted to show this too. And now we go into the new released content. Currently, we're working on the direction on continuing content for charging. Here is an update, but there will be a new course also soon. And the second part we are currently working on is encryption or cryptography, where we have 2 new courses released recently. So charging communication between EV and EVSE, we already had this course, and we've been adding some additional content explaining the so-called high-level communication in more detail. Just having a look at the course, the structure is more or less these two parts you need. It's the pilot signal, which is establishing the communication, and then you have a high-level communication where a lot of data is exchanged. And within this high-level communication part, we add some additional content. And the content we added is on the power line communication using OFDM, and also some home plug GreenPhi information. So we'll have a short sneak peek into power line communication and OFDM right now. So I make it a little bit bigger so that you can see more easily.
In high-level communication, according to ISO 15118, the message transfer is based on a power line communication specified by the home plug GreenPhi, which in turn is based on the OFDM.
So to learn more, it's interactive to stay awake while learning.
In power line communication, information transfer happens over an already existing power cable. In EV charging, the existing control pilot channel is used for transfer, and no protocols of IP-based networks are used for communication. For systematic order of these protocols, the OC model is used.
And now the term OFDM.
OFDM stands for orthogonal frequency division multiplexing. In order for the communication between vehicle and charging station to work, the PLC signal has to be modulated onto the existing PWM signal. The used modulation method for this is OFDM.
Okay, this is it for charging right now. There will be further content to be published soon. We've been working on cryptography and have been releasing the courses Introduction to Cryptography and then also the encryption method. Introduction to Cryptography contains the content, some cryptography basics to explain how it's working in general. And then the encryption methods have different types. So there are symmetric encryption, there's asymmetric encryption, and a combination out of symmetric and asymmetric hybrid encryption. So we'll have a look both now in some sneak peek into different topics, one on cryptography basics and some information on symmetric encryption so that you get an idea what you can find in this course. For the course here, you have the same structure again. For the cryptography basics, we'll have the roles explained and also how the encryption is working. And then finally, Kerckhoffs's principle. What I really like is to get to know the different roles or protagonists within the communication. And this is why I'm now providing you with information on who are Alice and Bob and the other guys and girls.
Before we delve into the different encryption methods, we want to meet our protagonists. It has become common practice to always choose the same characters when illustrating methods or drawing up examples. Click on the buttons for more information on these characters. Best known are Alice and Bob. We will meet those two many times during this unit. Alice usually sends messages, while Bob receives them. If further communication partners are needed, we meet Carol and Dave. In our case, we sometimes need a third person who, however, does not have an established name. These two are our bad guys. If any communication is intercepted, it is usually done by Eve. Eve is our eavesdropper and is able to intercept data, but cannot change it. Mallory, in contrast, is more powerful than Eve. He is an expert in his field and can actively attack any communication channels. We usually meet him when we talk about man-in-the-middle attacks.
So this is just one aspect on the cryptography, and the next part in this course is symmetric encryption, and we'll have a look also on symmetric encryption. And there I chose the explanation of the problem behind and what you need to solve, that you are able to do symmetric encryption. And the topic here is the key exchange, how to address the key topic.
The question of how Bob can obtain Alice's key in a secure way leads us to the so-called key exchange problem. It describes the problem that one would technically need a secure communication channel when exchanging the key, or would need to encrypt the key itself. This key exchange problem is so significant because the security of the whole method depends on the secrecy of the key. In this context, we also want to consider the problems which can arise from the number of communication partners and their keys. Click on the buttons to select a topic. It is necessary that the recipient receives the key via a secure communication channel. Otherwise, third parties might be able to intercept the key. This would allow attackers to not only read any future messages, but also to change the content of messages or send their own messages. This could be prevented by using said secure communication channel. However, if such a channel would exist, the message itself could be already sent in plain text via this channel. To exchange an encrypted key is not possible, because how should the recipient decrypt the key? For this, he would need another key, which would have to be exchanged encrypted, for which he would need again another key for decryption, and so on. Let's assume we found a way to securely exchange our key. One problem, however, still remains. A rising number of communication partners means that the number of keys is also rising, since there needs to be one key per couple. If 3 people want to communicate, 3 keys are needed. If the number rises to 4, 3 new keys are needed, with a total of 6 keys. 5 people need already a total of 10 keys. In general, the formula is that n people need n times n minus 1 divided by 2 keys. As we see, the number of keys needed rises very quickly, which can easily become a problem itself.
So this was it for the introduction into cryptography in general, having a sneak peek into the basics and symmetric encryption. Of course, there's also asymmetric encryption and hybrid encryption. And the next e-learning course we've been releasing is encryption methods. Overall, we are providing 4 different encryption methods, which are 2 symmetric ones and 2 asymmetric ones. For the symmetric encryption methods, we have DES, Data Encryption Standard, and AES, Advanced Encryption Standard. Where do you need it? Just as an example, we've been talking about charging. In charging communication, according to the current standard, which is ISO 15118/2, TLS protocol, TLS 1.2 is used, and with TLS 1.2, the advanced encryption standard is applied. So for charging communication, encrypted charging communication, you need the advanced encryption standard, which is symmetric. For the asymmetric encryption methods, we have on the one hand Diffie-Hellman key exchange and then also RSA. Coming back to the example, with the encrypted charging communication, there will be, for charging communication, there will be a new standard version, ISO 15118/20, not 2, but 20. And in this version, TLS 1.3 applies. And as encryption method, then Diffie-Hellman key exchange is used. So we're really combining charging and encryption. So we'll have a look at one of the symmetric standards with DES, and then we will have a look at RSA. So here you see is symmetric encryption. This is the e-learning unit inside. DES, AES, make it bigger. And here I chose to show the process.
Data encryption standard combines permutation and substitution ciphers, which are applied to bit sequence.
I will just go back. So concerning the process of these mathematical terms behind, like permutation, substitution, XOR, modulo calculation, and so on, this mathematical background, it's just in the release process. It will be coming soon. So if you need know-how of these terms, then it's wise to start with this beforehand. So I'll just go back and start again.
Data encryption standard combines permutation and substitution ciphers, which are applied to bit sequences. In particular, we work with block ciphers instead of stream ciphers. This means that a 64-bit block of plain text is encrypted to a 64-bit block of ciphertext. The respective key has a length of 64-bit, where 8-bit form a checksum, the so-called parity bits. Hence, we also talk about a 56-bit key length occasionally.
Okay, this is just as an example for the process. But as you can see, there's a lot of information, also these encryption rounds and so on, functions, key schedule, further information. It's a comprehensive set to understand the DES standard. The next one I want to show is RSA. And there I chose more or less like the basic principle steps, which I explained, and we'll have a look at this too.
Before we discuss the actual algorithm, we want to speak about some basic principles of RSA. Click on the buttons from the left to the right. The RSA is based on the factoring problem. This describes the practical difficulty to determine the prime factors of a large number. Although this problem has been present for a long time, until today there is still no efficient and practicable method known to determine the prime factors. You have to keep in mind that in practice, numbers with several hundred digits are used. The factoring problem becomes particularly difficult for the product of two large prime numbers. We see that we once again encounter one-way functions. While the factoring of a number is very complex, the multiplication of two numbers goes quick and easy. The trapdoor functions form a subgroup of the one-way functions. With the help of an additional piece of information, also the second direction of these functions becomes easy to compute. For an illustration, you could think of a mailbox. Inserting a letter is possible to everyone. Getting the letter out of the mailbox is difficult, unless one has the key.
Okay, this was a sneak peek into this topic. And also they are the same, especially the mathematics and the key generation and so on are a little bit more complex than these basic principles going through. And I think you need to invest some time to deeply understand these topics. So this would be the thing for today, showing on the one hand charging and these new cryptography courses. I would like to then also go into the learning journeys just to have a short look at this. We are currently in a kind of a flow. We're releasing a lot of new content. So we'll have an update on Embedded Academy, what's new maybe in 3 weeks and again in 6 weeks, to show you all the new things we've been publishing and also describing. Concerning the learning journeys, we saw that it's as the content is growing and you have a lot of courses, it's not that easy to find your way around. So we try to describe, or we are describing certain job profiles and say, if you are doing this job, then we recommend to learn this, and this part of the Embedded Academy. And we also recommend a learning order so that you have like the basic know-how and then the next lessons building up on this. We described an embedded software developer with the classical embedded topics. And for this, the package with a 12 weeks access is enough. Other job profiles roles are more comprehensive. There's more courses, more content connected to this role. For example, if you have embedded software with a focus on some technology topics, some physical parts you're controlling, then you need, for example, a deeper background in electronics, electrical engineering, electrical machines, and so on. This we defined in here. We have quite recently added the measurement technology engineer for strain gauges. We have several automotive profiles for embedded software developers working within the automotive domain, and also like a role of a quality engineer. And we described profiles for e-mobility, which are more dedicated to charging and then fit for the infrastructure side, but to a certain extent also to the automotive side. We're currently in the process of releasing 2 further job profiles and also updating the descriptions. So having new courses, we are able to assign them to certain sections of job profiles and say it makes sense that you take this and this in addition. So we are currently in this process of releasing all this data. And this will come within the next 2 weeks. So there's a lot of going on. We are really proud of what we achieved and how we've been growing this learning landscape. And we are happy if you start to explore, and maybe you would just start with this, for example, free course on AutoSAR, for example. So this is it for today. I think it's enough information on what's new for Germany Friday afternoon. Others might have it in the morning. Thank you for taking your time, and I hope to see you again when the next time we go into details of either the new courses or the learning journeys, or maybe a plan out of this. We need to plan. I estimate that the next update will come in 3 weeks. Thank you for joining and have a nice day. Bye-bye.